Hello fellow beings, in today's content, I will be giving you a tutorial exercise on the proficient problems on how to solve properties of solutions in thermochemistry. So the first topic that I'll discuss is about the ways of expressing the concentration of solution. So what does concentration mean? Concentration is a ratio of the amount of solid to the amount of solution. You can also look at in this way. It is solute over solution, where the solute is the substance that gets dissolved, while the solution is the mixture of solvent plus solute. Concentration of solution can be expressed in molarity. Molarity is the most common unit of concentration, and it is the amount of substance in a certain volume of solution, and it is also called molar concentration. How is molarity expressed? So molarity is a unit of solution concentration. It can be calculated by the molarity is equal to mole solute divided by liters of solution, expressed as M is equals to mole over liters. Let's try solving a problem. What is the molarity of solution formed from 6.75 sodium chloride dissolved in water to make a solution with a total volume of 952 ml? So it's given 6.75 sodium chloride, which are the amount of solute, and 952 ml, which are the sum volume of solutions. So by finding the molarity, as I've mentioned earlier, use the formula of molarity. So now let's apply the formula. So 6.75 grams sodium chloride divided by 952 ml. Now we will use the dimensional analysis to convert grams to mole and millimeter to liter to come up with our final answer. We can use periodic table to find the molar mass of sodium chloride, and you'll come up with 58.4 grams of sodium chloride per mole of sodium chloride. So this allows to cancel out the grams. We now have units of moles per millimeter, so molarity is moles per liter. So let's convert the millimeter to liter. We know that 1000 millimeter are in 1 liter. When we solve this calculation, we find that the molarity is 0.121 mole per liter, or 0.121 molar. Let's proceed to the second topic, which is the colligative properties of solution. There are types of colligative properties of solutions, and one of these is the osmotic pressure. Osmotic pressure is the minimum pressure which needs to be applied to a solution to prevent the inward flow of its pure solvent across a semi-permeable membrane. Here is the formula to calculate the osmotic pressure, where the pi is the osmotic pressure, I the Van Hoff factor, C the molar concentration of the solute in the solution, R the universal gas constant, T the temperature. So let's solve our problem. 1 mole of table salt is dissolved in 1 liter of water at a temperature of 27 degrees Celsius. What would be the osmotic temperature of this solution? The molar concentration of table salt in the solution is 1 mole per liter is equals to 1 molarity. Since sodium chloride dissociates into 2 ions, so the value of the Van Hoff factor will be 2. Converting 27 degrees Celsius to the Kelvin scale, the required temperature becomes 300 Kelvin. The gas constants will be. Now we can apply the formula for osmotic pressure. Substituting the known values in the above equation, so we will have this equation. When we calculate this, we got the result pi is equal to 49.26 atmosphere. Therefore, the osmotic pressure of the 1 molarity salt solution is 49.29 atmosphere at temperature of 27 degrees Celsius. Before anything else, let's define what is thermochemistry. Thermochemistry is the study of the heat energy which is associated with chemical reaction and or physical transformations. Thermodynamics is a part of thermochemistry, where the first law of thermodynamics says that heat is a form of energy, and as what all other forms of energy is subject to, it follows the laws of conversion of energy. Here is the formula of first law of thermodynamics. So where the delta E term that's called the change in internal energy, Q, that is actually a symbol for heat transferred. W is the work that is done. So just to know a little bit about me more, let's go ahead and define all three of these terms. So again, the delta E, that's the change of internal energy, is a sum of kinetic and potential energies of the particle. And the heat is the flow of thermal energy caused by a difference in temperature. Work is the result of force acting through a distance. Let's try to solve the problem. Calculate the internal energy change for a process that absorbs 10.0 joules of work on the surroundings. Where we're gonna use the equation that delta E equals Q plus W equation. It's given 10.0 joules and 15.0 joules. So the Q, that's going to be 10.0 joules. So we have 15.0 joules of work that is done on surrounding. Since the work is done on the surrounding, which means it must be done by the system, so it's considered negative. So we have 10.0 joules plus negative 15.0 joules. When we calculate this, we got the result negative 5.0